Good day, grade 12. This is Pedagogical Science Institute for the people. Today we are doing physical sciences, acids and bases, which is question 8 on your questions and is going to be question 1.8 on your multiple choice question. So today we are going to look at acid and base as a whole, or we are going to revise acid and bases. So we are going to do everything that has to do with acid and bases. Then if ever we look at our examination guideline, we can see that chemical change have 92 marks. So it's a lot of marks, guys. And remember, in chemical change, we have 3 topics: rates of reactions, chemical equilibrium, and acid and bases. So today in this lesson we are going to cover acid and bases only. The other 2 topics will be covered soon by my colleagues. So as you all know that acid and bases sometimes they can become tricky. It's only because you didn't master the content well. But today you are in the right place on the right time. You're going to master everything correctly about acid and bases because they are more simpler, and especially when you're engaging yourself here at Pedagogical Science Institute for the people. So this is chemical change, acid and bases. We are going to start by looking at all definitions that are associated with acid and bases, because there are many definitions in acid and bases, and we are going to look at all of them and how to be able to explain those definitions without cramming them, but to understand the meaning so that you can apply them even in other scenarios. Then number 2, we are going to look at conjugate acid and bases, of how do they interact, and especially when you are about to do hydrolysis. Then number 3, we'll be doing hydrolysis as we have done conjugate acid and bases on number 2. Then number 4, we'll be doing reactions and indicators. We are going to look at which indicator is it suitable when this react with this. So why are we using that indicator? We are going to look all of this in depth. Then lastly, we are going to cover calculations, which are more than important when you are dealing with acid and bases. So as we have said, we are going to start by defining all the acid and base definitions. So now we are going to start by defining acid and base according to Arrhenius theory. As you all know that we have 2 theories. We have Arrhenius theory and we have Lowry-Bronstein theory. So grade 12, when they say define acid and base, you need first to check according which theory, because sometimes learners they swipe the 2 definitions such a way that when they say define acid according to Lowry-Bronstein, the learner is going to give according to Arrhenius, which is wrong. The examiner won't make you correct. They're gonna make you wrong because you didn't answer the way they've asked you. Yes, you have stated the correct definition, but in a wrong space of time. So you need to be careful of that. So when they say define acid and base according to Arrhenius theory, it's whereby you are going to say acids they produce hydrogen ion or hydronium in aqueous solution. Acid they produce hydrogen ion or hydronium ion in aqueous solution. We are trying to say when acid they are in aqueous solution, or when acid they are in liquid, they are going to produce what? Hydrogen ion. Why are they producing hydrogen ion? Because we know that hydrogen they has to do with what? With acid. So according to Arrhenius theory, when acid they are in aqueous solution, they are going to produce what? Hydrogen ion or hydronium ion. Hence, base, when they are in aqueous solution, they are going to produce what? Hydroxide ion. So base, according to Arrhenius theory, we are saying bases they produce hydroxide ions in aqueous solution. That is the two difference. Acid, they produce hydrogen ion in aqueous solution, while base, they produce hydroxide ions in aqueous solution. Those are the definition of acids and bases according to Arrhenius theory. But when the examiner is going to say to you, define acid and base according to Lowry-Bronsted theory, it's whereby you are going to say acids are proton donors, bases are proton acceptors. So this is the whole story. Arrhenius says they produce hydrogen acid when they're in aqueous solution. Then Lowry-Bronsted say, no man. Yes, they do produce hydrogen ion when they are in a aqueous solution, but they donate with what? With that hydrogen. So Lowry-Bronsted theory, he's saying acid are proton donors. Which proton are they talking about? They are talking about the H that they are about to donate. Then bases are proton acceptors. Which proton is the H? As you know that H is hydrogen, and a hydrogen in our periodic table, they are in the first group. So they have a cation. They are cation and they have 1 at the top. So we are saying acids are proton donors, bases are proton acceptors. So acids, they donate with that H, and bases, they are going to accept that H whenever they are reacting. So those are the definition according to Arrhenius theory and according to Lowry-Bronsted theory. Then, as acid, they are donating with their hydrogen ion to bases whenever they are reacting. We have two types of acid. We have strong acid, we have weak acid. Strong acid and weak acid. How are we going to differentiate that this is a strong acid, this is a weak acid? We are saying strong acid, they ionizes completely in a reaction to form high concentration of hydronium or hydrogen ion. In other words, strong acid, they ionizes completely. So when you need to master the word ionizes. When they ionize completely, what is going to happen? The concentration of hydrogen ion or hydronium is going to be high because it has ionizes how? Completely. While weak acids, they ionizes partially or incompletely in a reaction to form what? Low concentration of hydronium ion. Why are they forming low concentration of hydronium ion? It is because they didn't ionize this completely. They just ionize this incompletely or partially. As they ionize this incompletely, meaning the concentration of hydronium is going to be low because it didn't finish its ionization. So we can see, or we can judge from that statement, that when it has ionized incompletely, meaning that the concentration of hydronium is going to be low. Then we need to master the examples of strong acid and weak acid, because when you are doing calculation, you need to know which acid is it reacting. Is it a strong acid or is it a weak acid? So strong acids, the most common strong acid, they are not all of them, but most common ones are sulfuric acid, hydrochloric acid, and nitric acid. Sulfuric acid, hydrochloric acid, and sulfuric acid, as you can see, hydrochloric acid, and nitric acid. Those are strong acids. They ionizes completely to form what? High concentration of hydronium. Then weak acid, we have acetic acid, we have oxalic acid, and we have phosphoric acid. Those are weak acid. All of them, the three of them, these three: acetic acid, oxalic acid, phosphoric acid. Those are weak acids. They ionize partially or incompletely. Then, since we have talked about strong acids and weak acids, we also have strong base and weak base. So strong bases, we are saying they dissociate. They don't ionize, they dissociate. Remember, acid, they ionizes completely, but strong base, they dissociate. Meaning strong base is the same definition as strong acid, but the difference now is that strong base, they dissociate. How? Completely in a reaction to form high concentration of what? Hydroxide ion, not hydrogen ion. Now they are going to form hydroxide ion. Hydroxide ion. You see, because bases, they have to do with what? They have to do with OH minus. This OH minus, it has to do with bases. So strong base, they dissociate completely in a reaction to form high concentration of hydroxide ion, which is the OH minus, and weak base, they dissociate partially or incompletely to form low concentration of what? Hydroxide ions. You see, these hydroxide ions. Then example of strong base is potassium hydroxide, sodium hydroxide, barium hydroxide. Most of the time, it's difficult to distinguish between the two whenever you are giving a chemical reaction. So you need to know them, you need to master them, grade 12. That strong base is KOH, which is potassium, NaOH, which is sodium, and barium hydroxide. They are not all of them here, but these ones are the most common one that the examiner used to examine us with. So example of weak base is going to be ammonia, zinc hydroxide, and lead hydroxide. Those are example of weak base. Then we have this one, ampholyte. I think everyone has encountered this with ampholyte. So ampholyte, we are saying those are the substances that can act as either base or acid. Those ones in a reaction, they can be a base, they can be an acid. It depending on the other reactant. You see, so those substances, we are saying yes, those substances, we are saying they can act as a base, they can act as an acid. You see, depend on the other reactant. For an example, it's H2O, don't forget, which is water, and sulfuric acid, H2SO4. And as we are talking about H2SO4, we know that it's a strong acid, but it can act as a base depending on the reactant. Then we have many types of acid. We have monoprotic acid, we have diprotic acid, we have triprotic acid. As you all know that mono means one, and di means two. You see, so monoprotic acid, those are acids that donate with only one hydrogen ion. Remember Laurie Bronsted theory. He said acids are proton donors, they donate with that hydrogen. So when we are saying monoprotic acid, those ones they donate with only one. Once they donate, they do not have any other hydrogen to donate with. Hence, diprotic acid, those ones they have two hydrogen ions. They donate with two hydrogen ions. Then we have triprotic acid. Those ones they donate with three hydrogen ions. Example of monoprotic acid is hydrochloric acid. Hydrochloric acid is HCl, as you can see. Once it can donate with that H, it cannot donate again. Hence, diprotic acid is H2SO4. It can donate and donate. So when we are calculating, it's very, 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 very important to master diprotic and triprotic, because sometimes that is why when we are calculating a pH, you will find the wrong answer because we didn't consider that acid you are calculating, it is a diprotic, monoprotic, or triprotic acid. Then triprotic, we are saying tri means 3. So triprotic acid, those ones they can donate with 3 hydrogen ions. For an example, H3PO4. You see, they can donate. As you can see that those H, they are 3, 2, 1. So you need to master that. So now we are going straight to conjugate acids and bases. We are done with the definition. Definition, they are going to be on your examination. You need to master them. So now we are going straight to conjugate acids and bases. So this is a question paper. We are going to do it together as part of revision. But they are saying A, what is the conjugate base of each of the following acids? What is the conjugate base of each of the following acids? We have HClO4, we have H2S, we have PH4, we have HCO3. So we need to answer them. So here we are given a conjugate base. You see, now we are going to give them a conjugate base. They've given us acid. So we'll start with HClO4. HClO4 is an acid. We need to provide the conjugate base for this acid. Remember Laurie Bronsted theory. He said acid, they do what? They donate with H. So let us donate to find the conjugate base. Let us donate. It's HClO4. When it donates with this H, what are we going to left it? We are going to have hence I won't be able to write very well. ClO4 minus. But it's ambiguous. But let me use an eraser so that we can start fresh. We need profession. Okay, it's HClO4. We need to donate that H to find the conjugate base. So we are going to have ClO 4. So let us look here. Here it's 0 on top of O. So here we're going to have what? Minus. So the conjugate base of HClO4 is ClO4 minus. Why? Because it has already donated with its proton, which is the hydrogen. Then let's do number 2. Let me erase. Let's do number 2. It's nice, guys. Physics is nice. So now we are having H2S. We are having H2S. It has 2 hydrogen. And remember, we said when it has 2 hydrogen, what does it mean? It's a diprotic acid. So it has H2. It is H2S. Now it's going to donate with only 1. Donate with only 1. Let us see what are we going to have. We are going to have H. You see? Then we are going to have what? S. Then we are going to have minus. See? Minus. There were 2 H. Now we are having only 1 H, which is HS minus. That is the conjugate base. Do you get how are we getting our conjugate base? I think you are even enjoying wherever you are watching this video. So let's wrap this. Do number 3. Now we're having pH4. It's going to donate with only 1. Only 1. We are going to have what? P. Then we are going to have what? H. Okay. There were 4 H's here. Now we are going to have how many, guys? 3. Then look here. It was pH4 plus. Because it has already donated with only 1. What are we going to have at the top there? We are going to have nothing. Because it's plus, now we are going to have what? 0 is going to be just neutral, which is pH4. Let us do the last one. Erase. See? Puff. Then let us do the last one, which is HCO3 minus. Only 1 H. It's going to donate with that H. Because it's an acid donate. So as it is only 1 H is going to donate, we are going to have what? CO3. We are not going to have minus again because that minus is already gone because it was an anion. Now it's neutral. If we're gonna go further, we're gonna have a what? A cation. So that's how we get our conjugate base. So I think it's very simple. Say number B. They are saying what is the conjugate acid of each of the following bases? What is the conjugate acid of the following bases? Now we are given bases. We know that according to Lorentz bases, what do? They accept. Wow, that is simple. They do what? They accept. Meaning now we are going to add H in everything we are going to come across. So the first one is Cn minus. So we are going to have H now, meaning it accepts. What does it accept? That proton. Which proton? H. So the conjugate acid of the following base is going to be, for Cn minus, is going to be H, the one that is already accepted, C, which is this C, and what? And N. Where does this N come from? Is this one. Then we won't have anything here. It was minus. Now we're going to have neutral, which is HCN. Do you get it? Let us take our eraser. No, let us continue. I'm going to write here, over here. Then now we are having SO42 minus is going to accept what? The H. So we are going to have H, then we are going to have S, then we are going to have O, then we are going to have the small 4, which is the subscript. We're going to have 4. Then it was 2 minus. As it was 2 minus, we are going on this side. If ever you're looking on your timeline, yes, it is a timeline in mathematics. I've done maths, I know maths. If ever you're gonna look at your timeline in mathematics, it's -2, is -1, is 0. You see. So now it's -2, meaning we are going to have what? Minus over here. Minus. I know when it comes to these charges, sometimes it's becoming more confusing. You need to consider your timeline. Okay, let me take you to the first one. At first we have Cn minus, but look at our answer, it's HCn. Why? Because it was -1, now it is gained, it gained a proton. A proton, it has plus, so it's going to have minus and a plus. That minus is going to cancel the what? The plus. Then we are going to have what? 0. Now we have -2. -2 plus 1. Where does that 1 come from? From the proton that is accepted. So that is why we're going to have what? Minus. That's where it comes from. I think now it's maybe a clear understanding of what is happening on the charges. So number 3, we are having H2O is going to accept. Is going to accept. So we are going to have H. Sorry for my handwriting, guys. Let me erase this. Technology, you know, is sometimes not on our side. So it's H. You see, it's H2. Now we are going to have how many H? 3, because it has accepted. H2O now acts as a base. So we are going to have H3. Oh, and we know this thing. What is it? Hydronium, which means we are going to have plus over here. So we continue. And the last one we are having, my eraser, erase everything. Then the last one we're having HCO3 minus. So H, we are going to have how many H's now? We are going to have 2, because it's a base, it has accepted. So we are going to have H2. You see, then we are going to have what? C. Sorry for my handwriting, guys. C, yes. Then it's going to be O. Then what? 3. Yes. Then as it was minus plus 1 is going to give us 0, which now we are going to have 0 here, which there is no need for us to write that 0. It's neutral. So yeah, that's how we get our conjugate acid and bases. Then let's continue. Let me erase over here. Now they are saying anhydrous oxalic is an example of an acid that can donate 2 protons and thus ionizes in 2 steps as represented by the equation below. We can see that this statement is underlined. An acid that can donate 2 protons. What does that mean? You have learned it, guys. I have told you. They are going to ask you in your final exam. So, an acid that can donate with 2, you know what does that mean? And thus ionizes in 2 steps as represented by the equation. We have 2 equations. We have equation 1 and equation 2. So, this oxalic acid is an example of an acid that can donate 2 protons. That is why it has 2 equations. The first equation and the second equation. The first equation where it donates with 1, and the second equation where it donates with the other 1. So 3.1, write down one word for the underlying phrase in the above statement. One word for the underlying phrase in the above statement. Which under this one, an acid that can donate 2 protons. What is it? What is the name of that acid that can donate with 2 protons? We have already covered it. We have said that acid is a what? We have said it's a diprotic. Don't mind the handwriting, guys. It's online. It's diprotic, as a fellow have indicated. It's diprotic. Diprotic, those ones are acids that can donate with 2 protons. Is which protons? The hydrogen ion. Then 3.1.2, let me erase this one. The ugly handwriting, because here we are working. So 3.1.2, write down the formula of each of the 2 bases in reaction 2. Now they are saying let us look at reaction 2 and write the 2 bases that we can see from those ones. How are we going to judge that this is a base? It's simple. We are going to apply Lowry-Bronsted theory. Lowry-Bronsted theory is the one that is going to say this one is the one that you are looking for. So the only thing that we know about Lowry-Bronsted theory is that those bases, they do what? They accept. So let us look at anyone that has accepted here. Okay, we have HCOO2. You see? HCOO2. Let's go over the equation. We can see that on the other hand is COO2 2 minus. So what happened here? It has H. Now the H is not here. It gained or it has lost. Obvious, guys. It is donated with that H, because at first it was having that H, but at the end the H is no more there. It's no longer there. So which means this one is an acid. We ignore that one. Then we have H2O. H2O, let's go to the other hand, it's H3O. Okay, what happened here? 2H, now there are 3, meaning this one has accepted. You see, this H has accepted an H. Shows the first base that we have over here, it's H. It's H2O. H2O is the first base that we have. Because why are we saying H2O? Because we can see that at first it has possessed only 2 H, but after the equation, or on the other hand, it has how many? 3, which it has gained. Then where is the other law? Where is the other? Because we can say that this reaction is reversible with this. We can see that it's reversible, meaning we can start this equation from this side, we can start this equation from this side, we can start it from this side, we can start it at anyhow. So let us look here, COO2, but when we come on this side, now it has H, it has gained. So meaning the other H that we have is going to be COO close brackets 2. You see, then we have 2 minus over here. So those are the 2 bases that we have. It's H2O and COO2 2 minus. You are just applying Lowry-Bronsted theory. Lowry-Bronsted theory is the one that is going to tell you which one. So 3.1.3, the formula of the substance that acts as an ampholyte in reaction 1 and 2. What is an ampholyte? We have said that an ampholyte is a substance that can act as a base or acid depending on the other reactant. So let us look here, over here. The first equation we have H2O. You can see that H2O in the first reaction can act as a acid, but in the second reaction it can act as a base. So the formula that they're asking us to provide them is H2O. It's H2O. Give a reason for your answer. Because in the first equation it has acted as a acid, then in the second equation it has acted as a base. That's how we encounter these type of questions. So still we are busy with conjugate acid and bases. Now they are saying the hydrogen sulfate ion HSO3 is amphiprotic. Amphiprotic. We need to consider this with done. Amphiprotic. So what is an amphiprotic? Amphiprotic still is the same as ampholyte. The substances that can act as base or as acid depending on the other reactant. So they are saying write an equation for the reaction HSO3 with water in which the ion acts as an acid. That is number 1. Then number 2, write an equation for the reaction HSO3 with water in which the ion acts as a base. You see? Yeah. So we need to write 2 equations. The first one, HSO3 reacts with water, it must act as a acid. Then the second one, it must act as a base. So we need to look all of that. So let's start with the first equation. We are going to have H S O 3 minus plus. Hey, let me erase this thing. It's not appropriate. Yes, okay. Then we're gonna have H for the first equation, guys. H S O 3 minus, it reacts with what? With water, plus H 2 O. See? As in, now this hydrogen sulfate must act as a, then we are showing the reversible, arrows. Then we are saying this hydrogen sulfate now must act as a base. So when it acts as a base, as an acid from the first law, because they are saying the hydrogen sulfate ion is amphiprotic, write an equation for the reaction with water in which the ion acts as an acid. As it acts as an acid, you know that an acid do what? Donate. So we are going to have what on this side? We are going to have S O, yes, we're going to have SO3 3, we won't have minus here. Then plus, what will happen to the water? Because the water, as this is an acid, the water automatically it's a base. So here the water we are going to have what? H3O plus here. You see, that is the first equation. It's HSO3 minus plus H2O. Then on the other hand, you are going to have SO3, which is sulfate plus H3O hydrogen. Then let's do the other equation. Then on the other equation, now it acts as a base. We are going to have SO3 minus plus, I want you to look at how we are going to do this, H2O. Then now we are going to throw our reversible arrows. Okay, now it acts as a base. What does a base do? It accepts, meaning that here we are going to have what? H2. We are going to have 2H, because here it was only one H. Then we are going to have what? SO3. Then plus, because this is a base, HSO3 now acts as a base. Automatically H2O now is an acid. So as an acid is going to do what? It's going to donate with only one H. So H2O here is going to have what? OH. Sorry, with that H minus. That's how the equation is going to look. So this equation is an acid where SO3 acts as an acid. Then this one, it's where it acts as a base. I think everyone gets how we arrive to our answer. The first one, HSO3, which is hydrogen sulfate, acts as an acid. That is why when you are looking at this side, it was having the H. When you look at the other hand, it doesn't have an H because it was already donated. Then this one, it doesn't have an H, but when you look at the other hand, it has an H. Let's continue. Then now we are going to look at our third topic, which is hydrolysis. Hydrolysis. So we are saying hydrolysis is the reaction between salt and water, or is the reaction of a salt with water. That's it. Whenever water reacts with salt, what is happening there? It's hydrolysis. So the first question is a multiple choice question. Which one of the following represent the product formed during hydrolysis? NH4. Which one of the following represent the product formed when hydrolysis? NH4. So how are we going to do this? We need to write the equation on our own. So we are saying on the definition, hydrolysis is the reaction of salt and water. So this is the salt. We are given the salt, which is N. We are given the salt, which is NH4 plus. This is the salt. We are saying hydrolysis is the reaction between this salt and what? And water. So now we are going to get the what? The water, which is H2O. Then now we are only interested on the product. What is it going to be formed on this side? So let us look at NH4 plus. Is this an acid or is a base? And let us look at H2O. Is this an acid or is a base? So NH4 plus, because we see this plus, we can judge that NH4 plus, and NH4 plus is an ammonium. So very or obvious, it is what? It is a acid. Then NH2, okay, this is an acid. This it is a what? A base. Yeah. So how are we going to go along with this? Now it's very simple. As this is an acid, this is a base. Acid, what do? They donate. Guys, you are doing one and the same thing. They donate. Donate what? Hydrogen. So on this other hand, we are going to have what? NH3. Because here it was plus, now we are going to have 0, because 1 minus 1 is 0. So this is a base. What do base do? They accept, meaning H2O is going to do what? Is going to accept. That is why on this hand we are going to have H3O plus. Exactly. So these are the products formed. These ones are the products formed. These ones. Yeah. So let us look from our multiple choice. Is A correctly? NH3 is NH3. H2O, no. So now we need H3O, which is wrong. The second one, NH4, NH3 is NH3. H3O plus is NH3O plus, which is correct. Therefore, the answer is B. You can see how we can. In multiple choice, guys, we don't just choose whatever. We calculate when it requires to calculate, or we do this equation before you can choose the correct answer. Okay. So now we are going to look at question 7. Also, it's a hydrolysis. So they are saying a learner dissolves ammonium chloride, which is NH4Cl, crystals in water, and measures the pH of the solution. Define the term hydrolysis of a salt. We need to define the term hydrolysis. We have already defined this with hydrolysis on the previous slide when we say hydrolysis is the reaction between salt and water. So 7.1.2, will the pH of the solution be greater than, smaller than, or equals to 7? Right, with the relevant equation to support your answer. So it's very simple. It's not that complicated. So I'm going to fetch my pen. We are having N. Why is my handwriting? Technology. Having N H 4 C L and H4Cl. So they are asking, will the pH of the solution be greater than, smaller than, or equals to 7? So when they are saying the pH is greater than 7, they are trying to say the pH, is the solution going to be basic? You see, basic. Smaller than, they are trying to say, will the solution be acidic? When they are saying equals to 7, they are trying to say, will the pH be neutral? So the first thing that we are going to do, we are going to separate here. We are going to draw a line over here. So yes, just like this one. We're going to draw a line. Then NH4. Where does this NH4 comes from? If ever you may think. Then we can see, no man. NH4 Cl Because for these two to combine, this salt, an acid reacted with the base to form this salt. So which acid have Cl? Then we can say, no man, this acid is hydrochloric acid. And H4, a base, it gained an H. What was the previous compound? It was NH3. You see here, original, it was N minus my A, and it was NH3. So NH3, it's a base, that is why it has gained, then it becomes NH4. HCl is an acid, it is donated with this H, that is why it has become Cl. So NH4Cl, you can see that now is a salt, meaning acid plus a base, it has formed this salt. So they are asking, I've taught you strong and low. Hydrochloric acid, is it a weak or a strong acid? Then we can say hydrochloric acid, no, it's a strong acid. What about ammonia? A weak or a strong base? Yes, we can say that ammonia is a weak base, meaning strong acid reacted with a weak base. Which one is going to dominate between the two? Is it a strong acid or weak base? Obvious, because the acid is strong, meaning that the salt is going to be acidic. It's going to be acidic. Why it is become acidic? It is because the acid that reacted to form this salt, it was strong, and the base that reacted to form this salt, it was a weak base. So if it was a weak base, meaning that the acid is going to dominate over the what? The base, in such a way that it's going to result for the salt to be acidic. As this salt is acidic, it means that the pH is going to be smaller than 7. Smaller than, it's our answer. Let's continue. Now we are going straight to reactions and indicators. Reactions and indicators. Now we are having this picture in front of us. I'm sure we are familiar with this picture. Since grade 7, we use this picture to study many things. So this is a pH scale. We can see that from 0 to 6, and the pH is acidic. Then 7, it's neutral. Alkaline, it's from 8 to 14. That's what we were talking about on the previous slide. So from here to here, from 0 to 6, it's from 0 to 6, we can say that we see that this is the acidic part, but 0, it's a strong acid. 0, 1, 2, 0, 1, 2, we can include 3. Those are strong acids. Sulfuric acid, nitric acid, hydrochloric acid. Then we have these 4, 5, 6. Those are weak acid. As you can see that they are near to become what? Neutral. So number 7 is neutral. Number 8 to 14, those is alkaline, or they are basic. Let us continue so that you can see why are we studying all of this. So reactions, we need to know this. acid plus a base together, it's gonna gives you what? Salt and water. Acid plus a base is going to give you salt and water. So in simple word, we are saying acid plus base is going to give you salt plus what? H2O. You see, acid plus base is going to give you salt plus water. So if the acid is a strong acid and the base is a strong base, then the salt is going to be neutral. Strong acid plus a strong base, the salt that is going to be produced is going to be neutral. If the acid is weak and the base is also weak, the salt that is going to be produced is also going to be neutral. Then strong acid and a weak base, because the acid is strong, then the salt that is going to be produced is going to be acidic. You see, it's going to be acidic, same as what we did on the previous slide, because on that previous slide we had a strong acid and a weak base. That's why that salt NH4Cl, it was acidic. So weak acid and strong base, it will give you a basic salt. You see, the salt will be basic. Why are we saying this? Why are we learning this? So whenever you're gonna encounter a strong acid and a strong base, the salt will be neutral, and the indicator that you need to use there is promothymol blue. Strong acid and strong base, neutral salt, the indicator is promothymol blue. Then weak acid and a weak base, the salt is neutral and the indicator still is going to be promothymol blue. Then strong acid and a weak base is gonna give you what? Acidic salt. And the indicator that is going to be used is methyl orange. Weak acid and strong base will give what? A basic salt. And the indicator is going to be what? Phenolphthalein. No, I'm joking. It's gonna be a phenolphthalein. So meaning strong acid and a strong base, neutral salt, indicator is promothymol. Weak acid and weak base, neutral salt, indicator is promothymol. Strong acid and weak base, acidic salt, methyl orange. Weak acid and strong base, basic salt, and phenolphthalein indicator. So I think we get this. Let's get an activity of what we are saying so that you can deepen your understanding. So let us look at this one. Choose the indicator methyl orange, promothymol blue, and phenolphthalein that can be used in the following reaction. Motivate. Then we have HCl. Yes. We have HCl, which is a strong acid, if you remember. Then NaOH, which is also a strong base. Then NaCl is going to be a neutral salt because strong acid has reacted with a strong base. Therefore, the salt NaCl, sodium chloride, is going to be a neutral salt. Therefore, which indicator is it suitable there? It's promothymol blue. It's promothymol blue. That's why we've said it's promothymol blue, because NaCl is a neutral salt since strong acid and strong base was used. Then 16.2 we have hydrochloric acid, which is a strong acid, plus sodium carbonate, which is a weak base. So NaCl will be what? What type of salt? Will be an acidic salt. Why? Because a strong acid reacted with a weak base. That is why the indicator we are going to use is a methyl orange. See, then NaOH plus HCl, NaOH again. Now it's a vice versa of number one. Number one, they started with an acid, now they started with a base. Still it's one and the same thing. So still we are going to use what? Bromothymol blue, ever since a strong base reacted with a strong acid. Let's move. Here it comes. Now we are going to do calculations. We are going to do calculations of, or we are going to do stoichiometry. Alright, as I have said, now we will be doing our calculations. So as you can see in front of us, we have a formulae which we are going to use when we are calculating. So the first formula here, let me take my pen, or let me take a pointer. Our first formula is N is equals to M over M, which is number of mole is equals to mass over molar mass. And bear in mind that when we need to calculate molar mass, we need to head our periodic table so that we can be able to calculate our molar mass. Then the following formula is concentration is equals to number of mole over volume, or concentration is equals to mass over molar mass times volume. Whenever they say calculate a concentration, you need to use that formula, number of mole over volume. Then we have N is equals to V over Vm, which is number of mole is equals to volume over V, when your volume is at STP. But because we are doing acid and base, the most important formula is pH, the pH, because you'll be calculating pH most of the time, and for you to calculate the pH you need to do stoichiometry. So that is why the other formulas, N is equals to M over M, C is equals to N over V, N is equals to N over NA, N is equals to V over Vm. You need to know them because you will get that calculation whereby you need to calculate a pH, but you are not given a concentration. You need to calculate the concentration first, then you need to calculate your pH. So you need to know how those formulas interconnect or interlink to each other. Then the last formula there is Kw is equals to concentration of H3O times concentration of OH is equals to 1 times 10 to the power negative 14, which is Kw is equals to concentration of hydronium. And hydronium, I need to emphasize this, hydronium, guys, you need to know that when we're talking about hydronium, we are talking about any acid. So whenever they say calculate the pH of sulfuric acid, you need to know that that sulfuric acid is the same as hydronium, because we are talking about this thing that acids, they donate, and they donate what? The hydronium. So when they say calculate the concentration of hydrochloric acid, which means we are going to replace that hydrochloric acid with what? With the hydronium. Then OH, which is hydroxide, stand for what? For all the bases. It can be sodium hydroxide, it can be potassium hydroxide. Any base is replaced by what? By that OH. So where do we imply this formula of Kw is equals to KH? Kw is equals to concentration of hydronium times concentration of OH. Let's look at the formula of pH. Let's look at this formula. Formula of pH. I don't know what is happening with my mouse. Seems like it doesn't want to work. Okay. Let's minimize it. Let's continue. It seems like it doesn't want to work. Why is it? Okay, let's continue. Let's look at this formula. pH is equal to negative log concentration of hydronium. So the pH formula doesn't have a hydronium. So for you to calculate pH, you need to have a concentration of an acid. And sometimes you'll be given a concentration of a base. So for you to calculate the pH, you need to change the concentration of a base to a concentration of an acid. How are you going to do that? You are going to do that by applying this formula of concentration of hydronium times concentration of hydroxide is equals to 1 times 10 to the power of negative 14. That is whereby you are going to use that formula, you're going to get to the formula of what? Of pH. So we're gonna see that whenever we'll be doing the calculation, as we are about to head to the calculations. All right, guys. This is our calculation. Our first calculation will be doing, and it's very simple calculation. All right. Let me grab my pen. All right. 9.4. Learners prepare 2 decimeter cubic. You can see this 2 decimeter cubic. 2 decimeter cubic of sodium hydroxide. Sodium hydroxide, we know very well that sodium hydroxide is a what? It's a base. Of concentration 0,1. We are also given the concentration. Wow, they love us. Calculate the pH of the solution. Learners prepare 2 decimeter cubic, which is the volume of sodium hydroxide, solution of concentration 0,1, which is the calculate the pH. I'm going to do like this so that this thing can be simple to you. We are given sodium, don't mind my handwriting, guys. Sodium hydroxide. Okay, we are given a volume, we are given a concentration. That's what we are told. Therefore, the volume we are given is 2. The concentration we are given is 0,1. That's what we know. The concentration of sodium hydroxide is 0,1 and the volume of sodium hydroxide is 2. Sodium hydroxide is a base. That's what you know. Then they say you must calculate what? The pH. So when we fetch our formula for pH, we know that pH is equal to negative log times concentration of hydronium. And hydronium is an acid. So we don't have any acid in here. And we can't substitute the concentration of sodium hydroxide to the formula because sodium hydroxide, as I have said, it's a base. So our first step, we need to convert this concentration of a base to a concentration of a acid. How are we going to do that? We are going to write our formula. This formula, we are familiar with this formula, we know it. Kw is equal to concentration. These square brackets, they means concentration. Concentration of hydronium times concentration of hydroxide is equal to 1 times 10 to the power negative 14. Therefore, how are we going to do it? Because we need the concentration of hydronium, we are going to say concentration of hydronium, the square bracket. That's why I've used the square brackets, because it's a concentration times, because now the concentration of OH, we know it because OH is similar to sodium hydroxide. So the concentration of sodium hydroxide is going to be replaced by what now? By 0,1, because we were told that the concentration of this base is 0,1. That's why we're gonna say the concentration of hydronium times the concentration of the base, which is 0,1, is equals to 1 times 10 to the power negative 14. Then how are we going to get our concentration of hydronium? We are going to divide by 0,1, going to divide by 0,1 both sides. Therefore, the concentration of hydronium will give us what? 1 times 10 to the power 13. You can see that. You see. Then now we have the concentration of an acid, which is 1 times 10 to the power 13. Now we can be able to substitute this concentration to the formula of an pH. Therefore, we are going to say pH is equal to negative log concentration of hydronium, which is the formula. Then we are going to say is equal to negative log times. Now we are replacing this square bracket with round brackets because now we know the figure. Whenever you know the figure or the number, there is no need for you to repeat the square brackets, because the square bracket, they only represent what? The concentration. Therefore, now we are going to replace the concentration of hydronium with the concentration we get here, which was 1 times 10 to the power 13. Therefore, it's going to be negative log times 1 times 10 to the power 13, which means you are going to patch this in your calculator. Then you are going to get what? 13. And the 13 is correct. Why I'm saying that? It is because we know that sodium hydroxide is a strong excuse me, is a strong base. So if it's a strong base, it means that the pH must range from 12 to 13, 14. You see, yes, that can show you that this is a strong base. Let's do our number 2. All right, now we are doing our number 2. Our number 2 is more like simpler than number 1, although it has a lot of information, but it's simple. There is no need to panic. You are here at PSI. So our number 2 says, during a titration of sodium hydroxide solution in question 9.4, remember 9.4 is the previous question we did, with dilute oxalic acid, the learners find that 25.1 centimeter cubic of sodium hydroxide neutralizes exactly 14.2 centimeter cubic of oxalic acid. The balance equation for the reaction is as follows. We are given a reaction, then the question is, calculate the concentration of oxalic acid solution. Wow, that's very interesting and simple. So let me grab my pen so that we can analyze everything. They say during a titration of the sodium hydroxide, now they are mixing the sodium hydroxide, the one we calculated there. Remember that in the sodium hydroxide at first we had something like this. We have a volume, we had a volume of 2 and a concentration of what? And a concentration of 0,1. This is the information you know about what? The sodium hydroxide. Yeah, that's what you know. Okay, now they are taking this sodium hydroxide, the volume and the concentration, they mix it with the what? With an oxalic acid. And oxalic acid, it has, we only know the volume of the oxalic acid that they are mixing our sodium hydroxide with. It has what? It has dilute oxalic acid. The last one atom of sodium. Okay, it has 14. It has 14,2. This is the what? This is the COOH. This is the COOH. Yeah, the oxalic. This is the oxalic. Okay, they are saying they took this sodium hydroxide and mixed it with this oxalic acid, but the volume they took from the sodium hydroxide, the volume they used for this it was what, 25.1, which was 25.1. This is the volume they use from sodium hydroxide. They are saying same concentration, guys. The concentration doesn't change. The concentration doesn't change. The only thing that is affected is the volume. So calculate the concentration of oxalic acid. Now we need to find the concentration. What is the concentration of here? We need to find this. That's what we need to find, the concentration of this. So what is going to happen? From the two beakers we have a beaker for sodium hydroxide, we have a beaker for oxalic acid. For the oxalic acid, we need concentration, which doesn't have number of moles, which is impossible for us to calculate concentration at this point because we have two unknowns. From the beaker of sodium hydroxide, we have two unknowns, we have only one unknown. We have a volume which is 25.1. We're going to use this volume 25.1, and we have what? We have the concentration which is 0.1. You see this concentration 0.1. So the first step, we are going to calculate the number of mole of sodium hydroxide, because sodium hydroxide have the volume, have the concentration. So what is the formula? Sodium hydroxide number of mole is equal to concentration times volume is equal to, what is the concentration? We are told that is 0.1. What is the volume? We are told that is 25.1 centimeter cubic. Because it's in centimeter cubic, we need to convert it to centimeter cubic. How are we going to convert it? We divide this number by 1000. We divide centimeter cubic. Don't forget, we divide centimeter cubic by what? By 1000. Don't forget, by 1000 to get what? To get centimeter cubic. We divide centimeter cubic by 1000 to get centimeter cubic. So that is why it's gonna be number of mole of sodium hydroxide is equal to concentration times volume. What is the concentration? Is 0.1, we are told, times what is the volume of sodium hydroxide that was used in the oxalic is 25.1. Divide by 1000, it's going to give us 0.0251. Therefore, you punch your calculator, you're gonna get 0.00251 mole. Don't round your answer. Don't round your answer, because at some point it may give you the final answer to be wrong. So you will round only the final answer. Now write everything in there. Then now we have the number of mole of sodium hydroxide, which is 0.00251. We need to find the number of mole of what now? The number of mole of oxalic acid. How are we going to find them? We are going to use a mole ratio. A mole ratio. Therefore, we're going to say number of mole of sodium hydroxide, or number of mole of what we have, is to number of mole of what we want, which is oxalic acid. Then you go to your balance equation. You look at this coefficient. What is the coefficient of sodium hydroxide? Is 2. You write 2. Is 2. What is the coefficient of the one you want of oxalic acid? Is 1. You write 1 here. Then you say, what is the number of mole of sodium hydroxide we have calculated? Is 0.00251. What is the number of mole of oxalic acid? It's X. Why is it X? Because you are the one you need to calculate them. Then what are we going to do from here? You cross multiply these numbers. This comes this comes to this. You cross multiply. 2 times X is going to give you 2X. Look, this one times this one is going to give you 1. Therefore, X which is number of mole of C002 of oxalic, is equals to 0,0251 divided by 2. Why are we dividing by 2? Because it is 2x, and now we need what? We need x. Therefore, number of mole of C00H2 is going to give you, 0,001255 mole. Those are number of mole of what? Of oxalic acid. Now we have the number of mole of oxalic acid. We also have what? The volume. We need what? The concentration. Yes, we do have a formula for that, because now we are doing physics, we know formulas. Let us erase this. Let us erase this. Yeah, then we can see. Now we have the number of mole for this. Hey, my pick, don't run away from me. Yeah, its volume, its concentration. We have calculated the number of mole. We do have them. Now we need this concentration. How are we going to get the concentration? We have the formula. From the formula I've introduced to you, concentration is equals to number of mole over volume. We want concentration. We have number of mole, we have a volume. We can be able to find what? The concentration. Therefore, it's going to be concentration for oxalic acid is equals to number of mole over volume. What is the number of mole? Is the one we calculated using a mole ratio 0,001255 over what is the number, or what is the volume? We were given 14,2. Remember, I said when you are given the volume centimeter cubic, you need to divide by 1000. Therefore, it's going to be 0,0142. Therefore, you punch your calculator. Therefore, the concentration for oxalic acid is going to be 0,088 mole per centimeter cubic. I think it was fair enough. The first step, you calculate a beaker whereby you have full information. You have the volume, you have concentration. After that, you do a mole ratio to find the number of mole of the solution that you want. Then when you find the number of mole, obviously you have the volume, you can be able to calculate what? You can be able to calculate the concentration. Just use that procedure. Number of mole for the beaker that have all the quantities, mole ratio. After mole ratio, you'll find the number of mole of the solution that you want. Then now you will be having a volume and number of mole. Then it will be easy for you to get the what? The concentration. Yes, let us continue to our number 3. Wow, this is our final calculation. We'll be doing it, our final calculation. 8 marks. Wow, guys, every time, guys, when you are calculating acid and base, the last question on your question paper, the last question will head about 7 marks, 8 marks. So you will need to take all those marks. I can see that maybe it looks tricky on the screen, but I'm going to explain each step simpler for you so that you can understand what is happening there. So let us go to the question. Let me take my pen so that you can highlight everything. In another experiment, 30 centimeter cubic of sulfuric acid is added to 20 centimeter cubic of a 0.28 mole of sodium hydroxide solution in the beak. Calculate the pH of the final solution. Guys, before you calculate the pH, now the information is main. The information is confusing, but I'm going to make things simpler for you. They are saying here, now remember, let me draw my pick. I love to draw pictures, guys, because it makes the work simple. It makes our work simple. Okay, remember now, but in another experiment, 30 centimeter cubic of sulfuric acid, 30, which is the volume, 30, the volume, the volume. I'm going to say acid again, sulfuric, a base for what? For sodium. See, yeah, 30 centimeter cubic for sulfuric acid is added to the base. The base whereby the sulfuric acid is added is have what? You have 20 as volume. 20 as a volume. It has what? It has concentration of what? Of 0. Hey, don't mind my handwriting, guys. This upload technology. 0.28. Yeah. Calculate the pH of the final solution. The first step, which beaker have all the information, is the base, is the sodium hydroxide. So we are going to start by calculating the number of mole of what? Of the sodium hydroxide. That is why we're going to say number of mole of sodium hydroxide is equal to concentration times volume. What is the concentration? Is 0.02. No, the concentration is 0.28 times the volume. The volume is 20, therefore we're going to divide by 1000, therefore it's going to give us 0.02. Therefore 0.02 times 0.28, it gives us what? 0.056. Do you get that? Yes. Yeah. Therefore now we have the number of mole of what? Of sodium hydroxide. Remember, guys, on the calculation we did before this one, we knew that the concentration of sulfuric acid, it was what? It was 0.15. If ever you're gonna go back to the video, you can see this information I'm placing here. The concentration for sulfuric acid, it was 0.15 at first, meaning that they are saying the initial sulfuric acid was mixed with what? With this base, you see. So now we need to calculate the initial number of mole of sulfuric acid before it reacted. You see, the initial. They are saying now it has a volume of what? Of 30. Remember the concentration. I said the concentration, it doesn't change. The concentration, it doesn't change. It remains the same. So we are going to have this volume. Now we have volume which is 30 and the concentration which is 0.15. This concentration is the concentration we were given on the previous slide. So we are going to calculate the number of mole for the initial concentration for sulfuric acid. We are going to say number of mole of sulfuric acid is equal to, again, C times V. What is the volume? is 0,3. What is the concentration? Is 0,5. Therefore, our answer is 0,0045 mole. Therefore, that is why I've written here initial. Here, I've written what? Initial. To indicate that at initial stage, we have a concentration of 0,5. Then the volume, now we are told that it is 30. That is why I've written initial. Therefore, now we need to find the volume, the number of mole, of what? Of sulfuric acid, used. You see, the number of used. Meaning, now we are going to let me take my pen so that I can simply show you, because I know it's a little bit confusing, but it's not. Now we are going to do a mole ratio between the sodium hydroxide, this sodium hydroxide, the one that we calculated here. You see, the one that we calculated here, and what? And the number of mole of sulfuric acid used. You see. Therefore, how are we going to do that? We are going to let's remember our equation. At first it was 1:2. Therefore, we are going to use that 1:2. That 1:2 again. Therefore, what was the number of mole of sodium hydroxide that we calculated here? We find that is 0,056. Then we are going to say 0,056 is 2x. Then you cross multiply, as we already been doing this. After doing that, that's whereby we have come about along with this step. Let me show you this one. This one is come from the mole ratio. What mole ratio? This number of mole of sodium hydroxide, we were trying to get what? The number of mole of sulfuric acid used. You see, that is why we've used this mole ratio. So here are the number of moles of sulfuric acid what used. So okay, the number of mole of sulfuric acid initial, we just took the concentration we were given and the formula we are given, then we calculated them. The number of mole of sulfuric acid used, we use a mole ratio between what? The sodium hydroxide, because it's going to react with it, and what? And the sulfuric acid. Then we get the what? The number of mole that we used. Then now we need to find the number of mole that are in excess. Why do we need those ones? For you to calculate a pH, you need the number of moles that are in excess. How are you going to calculate the pH of a solution while the solution has reacted and it was a limiting reagent, or it was used completely? So you won't get that solution to calculate the pH. So you need to find the number of moles that are in excess so that you can calculate the pH. So how are you going to get the number of mole of sulfuric acid that are in excess? We are going to say number of mole of sulfuric acid in excess is equals to number of mole initial minus number of mole used. That is why we say number of mole of sulfuric acid is equals to 0,0045 minus 0,0028, which is number of mole of sulfuric acid initial minus number of mole of sulfuric acid used. Remember, the initial is the one that we were given at first, then the one that is used is the one that we got from the mole ratio between sodium hydroxide and the what? And the sulfuric acid as they were reacting. So the answer that we got is 0,0017. You see, now we got the number of mole in excess for sulfuric acid. We need to calculate what now? The concentration. Why are we calculating the concentration? It is because we know very well that for us to calculate the pH, we need what? The concentration. So we are going to say concentration of sulfuric acid is equal to number of mole over volume. The same formula that we're using. Number of mole over what? Over volume. Then What is the number of mole? Is 0,001700. Oh yes, 00. I forgot 00 here. Here, la. Yes, is 0,001700 over. Where do we get this volume? Where do we get this volume? This volume is the total volume. Is the total volume. Let me show you this volume. You see, Bella, this volume is 50, guys. So this volume is this 30 and the 20. You see, is this 30 and the 20. That is why we get a volume of what? Of 50. Then this 50, let me erase this. This 50, then it was divided by 1000. Remember, it was divided by 1000. That is why then we got what? The 0,005. Therefore, we get our concentration of sulfuric acid to be 0,034. Then after we get the concentration, please note here, note, sulfuric acid is a diprotic acid. That is why I told you that you need to know all the concept for acid and base. As this is a diprotic acid, it means that it donates 2 times. As it donates 2 times, we need to times that concentration by 2. You see, we need to times that concentration by 2 because it donates 2 times. That is why we are going to say H3O, concentration of H3O is equal to 2 times the concentration of sulfuric acid. Here you see, concentration of H3O is equal to 2 times the concentration of sulfuric acid, which is equal to 2 times, this is the concentration of sulfuric acid. We put it here, then we find what? 0,068 mole per centimeter cubic, which now is the concentration of what? Of this H3O. But we have multiplied the concentration of sulfuric acid 2 times to get the concentration of what? Of the hydronium, because it donates 2 times. It's H2SO4. That is why we have multiplied by 2 times. Therefore, we go to our formula of pH. pH is equal to negative log, open bracket. Now you have what? Your concentration. You just substitute your concentration here, as you can see. Substitute your concentration here, then you get what? Our pH, which is 1,17. And this pH is correct. Why I'm saying that? Because sulfuric acid, as you have been saying, it's a strong acid. So if it's a strong acid, the pH needs to range from 0 to 3. From there, you can see that this solution or this substance, it's a strong acid. I think, guys, we have come to an end of our calculation. If ever you have any problem or you don't understand anything, just contact any of us using those contact details so that we can help you in person, because I know that sometimes this technology thing can make things become difficult, but I think we are getting there, and I think we have enjoyed our calculation lesson. Oh yes, we have come to an end of our lesson for acid and base. This is the reference of where I have got all the resource. These are the resources where we get all the content we're delivering to you. You can go to Google and search acid and base compiled 2020 question papers. And I've also used the grade 12 textbook solution for all, which is a very good textbook, guys. You can use that textbook, you can find all the content you need. And physical sciences grade 12 examination guideline 2018 June paper 2, which was an SC examination, and 2020 paper 2 revision material. I think everyone got this revision material. If ever you are used to that, you can see that many of our calculation were extracted from that calculation. So guys, I think this was our end of our presentation. So, and I think you've enjoyed the lesson. And this is Mr. Matane, who was presenting you the acid and base lesson. So please subscribe to our YouTube channel and try to follow us in every social media platform. Pedagogical Science Institute is here for our people to provide you with the content you need so that you can do well in your examination. Good luck, guys, and all the best to your examinations that are about to start. All the best. See you next time. Bye bye.